Welcome back, everyone. All right, I've got you here some high order thinking questions based on applications to trigonometry. These are very important to test your concepts of applications to trigonometry, basically height and distance. All right, so let's go through the problems. All right, here we are given the angle of elevation of a tower from station A. All right, let me consider this station A and this OX as my tower of height H. All right, A is a station, and from this station, the angle of elevation is given alpha. All right, and it is said that from station B due west of A, there is a station B which is west of this A, and the angle of elevation from this station B is given as beta. All right, now it is said that this height of the tower we need to find in terms of this AB and alpha and beta. All right, so basically the generally this question is asked in terms of proving that prove that the height of this tower is AB sine alpha cos alpha, sorry, not cos alpha, sine alpha sine beta upon under root sine square alpha minus sine square beta. All right, generally this question is asked in this way and we have to prove this. Anyways, it's not given here, but now we know that we have to come to this conclusion. All right, it will be easy for us to understand where the question is moving. All right, now before starting the question, please understand this in this triangle, this height is perpendicular to this base, this height is perpendicular to this base as well, and this is also perpendicular. All right, ये तो understood है ये क्यों perpendicular है. Consider this now. It is said this point A is to the north of this and to the west of A. All right, this is to the north and this is to the west. So basically, this will be perpendicular. Basically, like two x's. All right, this is north, this is west, kind of this. All right, so it will be perpendicular. So this will be perpendicular. All right. All right. Now let's solve this. Look, consider triangle OAX. All right. So tan of alpha can be written as height h upon OA, right? Or I can write tan alpha as sine alpha upon cos alpha h upon OA, or this OA can be written as h cos alpha upon sine alpha. Consider this as equation 1, right? So similarly, in triangle OBX, I can write OB as, in this terms, only the angle will change. I can write cos beta upon sine beta. This will be my equation 2. I hope you have understood this step. If you apply the same steps, you'll find this OB as h cos beta upon sine beta, right? Now, apply Pythagoras theorem using Pythagoras theorem in triangle OAB. You can write OB square, which is the hypotenuse, as the sum of OA square plus AB square. All right, or AB square can be written as OB square minus OA square. All right, now from 1 and 2, put the values. AB square can be written as OB. What is OB? H squared is h squared cos square beta upon sine square beta minus h square cos square alpha upon sine square alpha, right? You can take h square common over here, so you'll be left with cos square beta minus cos square alpha, and it will be sine square beta upon sine square alpha. All right, so I can write AB square as h square. Taking LCM, denominator will be sine square alpha, sine square beta, and non-numerator will be cos square beta into sine square alpha minus this square cos square alpha into sine square beta, right? Now, further expanding, see, my expression doesn't have any cos. So convert the cos into sine, h square, sine square alpha, I'll convert cos square beta into 1 minus sine square beta. Similarly, this sine square beta will be as it is, and I'll convert this cos alpha into 1 minus sine square alpha, right? Now, sine square alpha on sine square beta, right? Expanding this, I'll get AB square is equals to, this is also AB square. I'll get AB square as h square sine square alpha minus sine square alpha sine square beta minus sine square beta minus and minus plus. So we're getting a plus over here. Sine square alpha sine square beta. In the denominator, it will be sine square alpha sine square beta, right? So sine square alpha sine square beta minus, and it's also in plus, so it will be cancelled out. I'll be getting AB square as h square sine square alpha minus sine square beta upon sine square alpha sine square beta. All right. So if I have to calculate the value of h, I'll take h square as AB square sine square alpha sine square beta upon sine square alpha minus sine square beta. All right. Take square root both sides, so you'll get h as AB sine alpha sine beta upon under root sine square alpha minus sine square beta. All right. So this is our final answer over here. Hence proof. If it's asked in terms of proving, so you can prove it like this, or if it's asked the height of the tower, so you can calculate it like this. All right. All right. This was the first question. Now there's another hot question. Don't lose your energy. All right. Now here is the question. The question says that the spherical balloon of radius r, this is a spherical balloon and its radius is r. It subtends an angle theta at the eye of the observer. So if A was the observer, so, and this was the eye of the observer. So at this point, the angle made by this balloon is theta. All right. So this angle will be theta by 2. All right. Using our properties from circles. All right. This angle will be theta by 2. This angle will be theta by 2. And this will act as a tangent to the radius, so it will be perpendicular. All right. We are not mentioning it over here. We'll be simply using it. So that's why I've already marked it in figure. Okay. You can also mark it in your figure and write it. No need to mention the properties used over here. So this is clear. Also, it is mentioned that if the angle of elevation of its center is phi, now, from the eye, the angle of elevation of the center is given, it is phi. This is where it is 5. All right, or 5. You can read it by any way. So this is 5. All right. We have to calculate the height of the center of the balloon. So this OB, I'm considering it as H. Okay. We have to calculate basically the value of this height OB. So let's start. First, I consider triangle. Let me select blue pen. All right. So in triangle AOC, all right. If I apply sine of theta by 2, this is theta by 2, sine of theta by 2, what will I get? Perpendicular upon hypotenuse is OA, right? So I can write OA is equals to, or just keep it as it is, no need to write this, consider this as equation number 1. All right, now in triangle OAB, in this triangle, similarly I can write sine of phi as this OB, which is the perpendicular, upon again OA, which is the hypotenuse. All right, and I mentioned OB as H, so I'll write H, which I need to calculate the height, and OA will remain as it is. Consider this equation number 2. Now I'll divide equation 1 by equation 2. All right, if I do this, I'll divide this, what will I get? I'll get sine theta by 2 upon sine phi is equals to R upon OA into H into OA. It was H upon OA, so it will come up. So OA will cancel OA. So we'll be getting this. If I take my H over here, what will I get? R sine phi upon sine theta by 2, or I can write my result as R sine phi, and 1 upon sine theta by 2 is cosec theta by 2. All right, so this will be my final answer. This will be my height. Now this was really easy, no? You have to calculate, just you have to make 2 equations, just divide equation 1 by equation 2, and you get your answer. All right, so this is the height. Only what is important is how you make this figure. All right, if you get any query, please do let me know. Hope you enjoyed the video.